Hello, this is the second lecture in this section, Cognitive Models of Language, and in this lecture we are going to look at learning the meanings of individual words. When I talk about learning the meaning of words, I'm talking about something as simple as learning to say apple for an English-speaking child when they want to refer to this red, round, juicy fruit. This sounds like a very trivial task if you think about it. And actually, for centuries, the researchers also treated it as a trivial task. They assumed that this is very easy to learn. All the child needs to do is to hear the adults refer to this word by pointing at the fruit and saying apple, and then the child would learn the association between the label and the object. However, it turns out that this is actually a much more complicated task that at the beginning they thought it would be. Let's look at a more realistic situation. Let's say the child is taken to the zoo and standing in front of a chimp section, the mother or father say the chimp eats apples. Now, assume that you are the child and you don't know anything about the language. You don't know any words, you don't know anything about the structure of the sentence. So your first challenge would be to figure out which part of this complex scene the utterance actually refers to. It could mean a black chimp is sitting on a rock, the chimp eats apples, there are 2 red apples in his hands, or several other different messages. So this is a challenge that's referred to typically as referential uncertainty. We don't know, if we don't know anything about the language, we don't know which part of the scene an utterance refers to. So we are uncertain about that. Even if we did know that the sentence refers to a particular aspect of the scene, still we have to figure out which part of the sentence refers to which component in the general meaning of the scene. For example, we have to figure out that the word chimp refers to this black, very big animal, and the word apple refers to the fruit, and the word eat refers to the actual action of consuming the apple by the animal. So still, this is a major step to take. It's not really trivial. And finally, there's usually a lot of noise in the environment. Not only part of the sentence could not be clearly heard by the child or by the learner, there are certain parts of the scene that can be masked. It could be that the sentence talks about something that's not even within the perceptual field of the child. For example, the mother might say, "Daddy went to the gym," and the child cannot see daddy or the gym. So there's usually a lot of noise that the learner has to deal with. So I'm summarizing these challenges in one slide, but you can now appreciate how difficult the task is to learn a real-life vocabulary just based on this noisy, ambiguous, and complicated data that children receive. There have been several learning mechanisms that have been suggested by the scholars that might be at play when learning the meanings of words. The very first learning mechanism that has been suggested is, as I mentioned on the very first slide, a simple associative learning mechanism. So here, the idea is that experiences and ideas reinforce each other. If a particular word form is repeatedly used in the presence of a concept, then there is an association formed between the two. You all are, I assume, familiar with Pavlov's dog. The idea is that if every time the dog hears a whistle, there is some meat power around, then the dog will salivate in the presence of the meat power, but gradually the dog will actually associate the bell ring with meat power, and so it would salivate even when there is no meat power present. And so the idea is that the same kind of association is being established between words as labels and reference as concepts. But as I told you before, this simple mechanism really doesn't deal with the complexity and the ambiguity of the data that's available to language learners. Another mechanism that has been suggested in the literature for learning the meanings of words is to rely on a range of biases or principles or underlying assumptions, or in other words, using a toolbox for restricting the reference of each word. So this could be very elaborate biases such as the whole object bias, as in novel words are usually used to refer to the whole object and not to parts of it. Taxonomic bias, labels usually refer to objects that are at a basic level of a taxonomy. That means that they are more likely to refer to a dog than to talk about an animal or a German Shepherd. And in addition to that, it could be that learners rely on social and visual cues to narrow down the reference of the words that they hear. For example, it has been shown that adults try to establish some form of joint attention by using their gaze or by pointing at things. By pointing at things that they want to talk about, and children learn to become or are innately sensitive to these cues. A third class of learning mechanisms that has been suggested that's at play when children learn the meaning of words is called cross-situational learning. This is an interesting idea. It's simple, but it's very effective. The idea is that if you hear a sentence like dog is playing with a frisbee while watching the scene that I'm showing you, where a dog is actually playing with a round plastic toy, and then 2 days later you hear the same word being used in a completely different context, such as she's throwing the frisbee, where now in a different setup a woman is playing with a similar toy, children and adults have been shown to be sensitive to these co-occurrence of a label and an object in different scenes. And that's what cross-situational means. So the word has been used in the presence of the same object, even though the situation has been different. And children can collect such evidence and over time decide that probably this co-occurrence is not accidental. It is because the word frisbee refers to this round plastic toy. Now, one thing that we have to keep in mind is that whatever theoretical account that we come up with about how children learn the meanings of words, this not only has to explain how they learn the meanings of words in the presence of noisy data, but also it has to explain the developmental patterns that have been observed in children. There are several developmental patterns that have been studied in children. For example, it has been shown that learning the meanings of words is very slow at the beginning, but then suddenly children seem to take off. So they start by learning a couple of words per week, and then they reach a stage where they learn several words per day. And this goes on for a while and then slows down again. This is called vocabulary spurt, and that needs an explanation again based on our theoretical account of word learning. Another pattern that has been observed is what we already talked about. It's called fast mapping, and it refers to the tendency of young children to map a novel word to a novel object in a familiar context. So if you tell the child to give you the DAX when there is an object that she or he has never seen before, it's very likely that they will point to that novel object. And finally, a common developmental pattern that has been reported in the case of young children is their tendency not to be willing to learn second labels for objects for which they already have learned the labels. So if they know a word for referring to a concept, they're not willing to use a synonym or learn a synonym for the same concept. This is obviously only at the very early stages of learning. Eventually they will learn the synonyms, but at least at first it seems that they are more willing to learn a one-to-one mapping for words and labels. So I have put some extra information about each of these patterns that you can go and look at. But the whole idea is that your model has to explain these patterns. So how can you explain that the learning rate is slow and then it suddenly speeds up? How can you explain that they don't want to learn synonyms at first, but then they eventually start learning them? One solution to this challenge has been that maybe children start simple. Maybe they start with a very simple learning mechanism such as associative learning because their brains haven't been developed yet. But as they grow older, their brain develops more and then they shift or switch to a more sophisticated learning mechanism such as cross-situational learning or referential learning. So this proposal has been around, whether the underlying learning mechanism changes during the development of children. As I said before, there's also a bunch of task-specific biases and constraints that have been proposed. For example, it has been proposed that children follow a principle of mutual exclusivity. They assume that words have different meanings from each other. And therefore, that's why they show this fast mapping pattern. They assume that if you have an apple and a novel object on the table, and then the experimenter asks them to show them the DAX, then DAX cannot refer to apple because they already know a word that refers to apple. And there are several such biases and constraints. But still, this doesn't really explain how these biases come into play or are abandoned after a while. Another proposal has been that maybe it is the statistical properties of the input and the learning process together that lead to such change of behavior. So it's not really about a change in the learning mechanism, but following the statistical properties of the input. So these suggestions have to be tested and they have to be mapped and matched against the data that children have access to and the patterns that this data and the learning mechanism lead to. And that's where the computational models come into play. A computational model in this case is a very powerful tool because you can simulate the learning mechanism and then you can feed it with realistic input similar to what children have access to, and then you can try to reproduce the experimental patterns using the learning mechanism that you simulated. So does the model imitate the experimental patterns that are observed in children? We also want to know whether a certain learning mechanism can explain the whole range of a developmental pattern or whether we need to implement a change in the process in order to replicate the full range of a developmental pattern such as vocabulary spread, for example. So in the next video you will see that we will look at a number of models that have been developed to simulate the process of learning the meaning of words in children and how each of them tries to replicate some of these patterns that we talked about today.